Hi guys, and welcome to the day 17 of my stream. Let me remind you first what I'm working on. I'm working on a React app, which is an encryption app. Currently there is only AES encryption. Let me show you. So that's what's happening currently. We have some text in the input. We select what to do with this text. We have some key and IV generated, and then we see the output. I have different methods of encryption. Oops. Yeah, that's what's happening. So basically, in the last stream, there was an issue. Hold on a second. So in the last stream, there was an issue with the ECB encryption mode. The issue was related to the fact that I still used IV for ECB, and it turns out IV is needed only for CBC mode. For ECB mode, we don't use any IV. So what we see happening now, I changed actually off screen. I made some changes. I change IV to basically nothing when we change to ECB mode. But what happens now when we go back to CBC after that, we see error invalid IV length 0. So this scenario we should check. So I should add a spec for this scenario. When the user changes encryption mode, AES encryption mode, from ECB to CBC, and UIV should be seen, and U random IV should be seen in the IV input. Okay, now here when the user changes AES encryption mode to ECB from CBC, IV should be removed from the IV input. Let's say the value should be removed from the IV input. And and IV input should become disabled. And the IV input should become enabled again, right? So let me first start with this one. SPEC31. From ECB to CBC. This one should already succeed. First, let us select mode. It is called variation input here. TRS variation input, select, and we select ECB. By default it is CBC, but we should select also AES encrypt. Okay, and now we want to check IV. IV input, so this one. IV input, select, should have, okay, should have value empty string. So this selector applies to the IV selector element, so this element, IV input. This selector applies to the IV input. This selector applies to the transform type input. This is the transform type input. And this selector applies to the variation input. Actually, it's called mode, to the mode input, to the mode drop down, you can say. So this one is not even a select. IV is not even a select, right? It's input actually. Alright, and so we are making sure that value is nothing, and here we should check that it's not nothing, so that we have some key after we select it. So first we select AES encrypt option, this option. Then we make sure that there is some key here in IV, right? Because by default it will be CBC mode. Now we select ECB mode and make sure that IV now has nothing basically. Also we need to make sure that it is disabled. Let me check if Cypress has assertion for that. Should be disabled. Yeah, it has. And here it should not be disabled by default. Should not be disabled. So let me make this test the only test we're going to run, and let us start it. Okay, so everything succeeds because yeah, everything is correct. We selected ECB, now it's disabled and there is no IV. But now SPEC30, so SPEC31 we can move to done. Now SPEC30, when we change it back from ECB to CBC, now we should again have some IV there, right? But we don't, so it will be the only test for now. So I will immediately set it as only. So now what we do same thing as we did here, but in addition to that, we also change it back to CBC after that. CBC. So this one actually should be before that one, but okay. To CBC, and now we make sure that everything as it was before. That is, that input not disabled anymore, and it has some value. Let me run this test now. Okay, it's not disabled anymore, but it actually has empty string as the value. So that's where we should fix, that's what we should fix now. So let us go to our reducer. This is where we set IV to empty string if variation is ECB basically. So if variation is CBC, then we just need to create a random key. I'm using crypto random bytes, and key length should be 16. Let's see if our test succeeds now. Yeah, now it succeeds. But this is wrong encoding. Actually, we should have a way of checking the encoding too. I'm not really checking the encoding currently. Okay, so now this point also works. Now let's check point 28. When the user changes a transform element to be AES decrypt element, the text in the output panel text area should change to the decrypted text provided key IV, mode, key length, and input are all correct. So this one is related to checking if AES decrypt works, and this one is related to checking if AES encrypt works. We already have encryption, so maybe we could check that one first, but we would need to run this encryption or decryption ourselves in Cypress. For this we could use CY task CY task event name and arguments. So inside the plugins file we need to define our task. So let me try to do that. Plugins index. Okay, so here we define our plugins. How do we call this? On let's say AES encrypt. Okay, and here we'll have our parameters, which is IV string, base64 string, um, key string, okay, this is JS. What am I doing? IV key this, yeah, what am I doing? Uh-huh. And here we should on task. Okay, that's what I did wrong. On task, and here all the tasks. So here AES encrypt should come here. So what are we going to take as arguments? First of all, text to encrypt, right? And then key, mode, key length, IV. I think we should take it in an object so that we might omit some of them. Which means we can use crypt directly here. We could use node crypto, but maybe we should try something else so that this is a third-party library, I guess. Create cipher IV. AES. Now key length and mode CBC or ECB. Let me look how I do this actually. Yes, and these will probably be strings. I should use buffer. Oh, not here. Oh, this is just algorithm. I need to create key using buffer from key base64. We assume that key format will be base64. Buffer from IV base64. Okay, and then we do cipher update and buffer concat and return encrypted, right? This should be called plain text. This is the term in cryptography. The thing which you encrypt is called plain text. The result of the encryption is called ciphertext. So this we may call ciphertext to be more correct in cryptographic terms. Okay, so this should do AES encryption. But what I don't like is the fact that it's actually using the same code which we're checking. But let me try doing this now. when the user changes a transform element to be AES encrypt element, the text in the output panel text area should change to the decrypted text provided key IV mode, key length, and input are all correct. Okay, so let's write a test for that. This says number, what is the 29? So it should be between this and this. So let's first change it to AES encrypt. Then we'll have some random key, some random IV, right? I would try to get, actually, what if I do it with a sync and use my own promise, like this const key and equals. I know Cypress does not really support promises. I will try to check. Key, how much we can use from it. Okay, so this is CY get. Invoke. Resolve key. So we should end up with key here. And we want the IV2. Oops, resolve text, it should say. IV input. Key and IV, we have both here. Wait, new promise I meant, of course, not the promise itself. So now we want to use CY task AES encrypt, which we just defined. We defined here our task AES encrypt. And I would also get text from plain text from the input. What is it called? Input text area, I think. TRS input panel text area. I think I can do that. Text area invoke invoke val. I used it incorrectly here. And then here too. Okay, here we have our plain text. So now we can call plain text key mode key IV mode and key length. Key length we can get from this select. I mean mode we can get from this select. TRS transfer